Hello students, welcome to PW Gulf, and yes, today I am back with the ultimate recap of your one more chapter, that is nothing but sound. So yes, I will be completing the whole chapter here, and certainly we will revise at what are the concepts that we have to study the moment we are going to talk about sound. So all of you, there are lot of sounds around you, and certainly there are lot of instruments that produce sound. So how sound is produced? What exactly sound is? So when we say sound is a form of energy, how sound is a form of energy, and also how sound can propagate, how it can travel from one medium. Certainly, yes, we say sound is nothing but a traveler. So why we are using this term? In this chapter we will understand all about sound, and yes, we are going to try to cover all the important topics. So without any further ado, let's start with the first thing, that is nothing but, yes, we need to understand about wave and particle. So all of you, when we use this term wave and particle, how they are associated with sound, that I will understand. But before that, let's start with our story. So all of you, in order to understand, in order to get the understanding of wave, there is a story. So all of you, there were two kings, King 1 and King 2. So let's say that, okay, there was King 1 and King 2. They were best of friends. Now what happened? King 1 thought that, okay, I will keep a feast and I want to invite my friend. So he appointed a messenger and gave the message through a scroll to that messenger. So let's appoint the messenger. So here is the messenger. Okay, so he told the messenger that, okay, you go to kingdom 2 and meet my friend and give him this invitation. So yeah, messenger followed the same pattern. So yes, messenger went. But yes, as the kingdom was pretty much far away, messenger took 2 days. Now, King 2, eventually, yes, he was very much happy. He said, of course, I will come. Now, taking the message of King 2, messenger came back taking 2 days. Now, this simple communication process, it actually took 4 days to complete. Very longer time taking process, right? Now here, King thought that, okay, there should be some easy process. I want this process to actually take place in lesser amount of time, because over here, it is taking 4 days, right? So 4 days. So what he did, he appointed lot of messengers, let's say 10 to 15 messengers, and made them stand in a line. So yes, messengers, they were standing in a line. Okay, messengers, they were made to stand in a line, and King 1, he shared his message. Now, messenger 1 took that message and shared it to messenger 2, and messenger 2 to messenger 3, and so on and so forth. This process took only 1 day. And the message from King 2 also came back. So yeah, following the whole thing up, it also took 1 day. So everyone, the whole cumbersome process of 4 days jot down to only 2 days. Right? So over here, can you see the message getting transferred? Right? Creating a disturbance. So this disturbance is nothing but your wave. Similarly, the messenger over here, they are nothing but the particles. Similar way, you can see this thing in your classroom as well, that when your teacher is sharing the question paper, she will give you the question paper. You are going to take one and then pass it on. Similarly, the next one will take one and pass it on. So all of you, the question paper that is getting traveled, that is nothing but the disturbance being created, that is nothing but your wave. Okay, and yes, students over there, they are the messengers, or you can say particles. So all of you, when we use this term particle and wave, so particle is the smallest quantity, right? And certainly we say particles are very important for a particular disturbance to be created as such. Okay, although there are some other waves as well, we are going to talk about that. Yeah, so when we say that, okay, the particle certainly over here is the smallest matter. Okay, what is the wave? The disturbance that is created there in the medium itself. Have a look, the scroll getting transferred, the question paper being transferred. Yeah, that is nothing but your wave. So wave, everyone, yes, is nothing but the disturbance that is getting created. Over there, you can say energy getting transferred, energy getting transported. Okay, so all of you, when we use this term that okay, wave and particles are nothing but the smallest matter. Of course, these particles, they will be creating the wave, or you can say they act as a source, or you not say like the source as such, but yes, they act as the medium over there for the disturbance to be propagated. Okay, so all of you over here, wave can be described as a disturbance that travel through the medium. Okay, disturbance. Yeah, transporting the energy. Okay, from one location to another. Yeah, now we have some types of wave. So all of you, let's start with the types of wave. The first type of wave will be nothing but our transverse wave. Okay, now we will understand this with example only. So all of you, I hope you have heard of Mexican wave, right? Certainly, let's have a look over here. So there are 4 kids standing in a line and they are holding hands. Okay. I'm not that good at drawing, but certainly I'm trying, okay. So all of you, they are holding hands, right? So now, let's say, kid 1, kid 2, kid 3 and kid 4. Okay, now the first kid out of the blue started to stand up and sit down. Okay, then the next one stood up and sit down. Yeah, then third one did the same and the fourth one did the same. So all of you, the disturbance started from kid 1 to kid 4. Right? So the disturbance, what is the direction of disturbance? Disturbance, everyone, I am saying. Disturbance is moving from student or kid 1 to kid 4. Yes or no? Right? Left to right. Yeah, this is the disturbance. What do you mean by disturbance? Disturbance is nothing but your wave only. Okay, so wave direction. But how your kid is moving? Standing up, sitting down. Standing up, sitting down. Yeah, so when I say that okay, how the particle is moving, you are going to say particle is moving up and down. Okay, so let's draw it properly. This is the direction of wave. Okay, and this is how particle is moving. Now all of you, can you see disturbance? Of course, particles are here, right? Particle is moving. Okay. Now everyone, when the particle is moving in 90 degree, have a look now, 90 degree over here. When the particle is moving in 90 degree with the direction of wave, you are going to say that yes, this type of wave is transverse wave. In Mexican wave also, people in the stadium, they are standing up, sitting down, standing up, sitting down, standing up, sitting down. The Mexican wave, it starts from the stadium's one end and it will move to the other end of the stadium, right? But how the kids are moving? The kids are going to move, or the students or the people over there, how they are moving? They are going to stand up, sit down. Okay, so when particle is moving in 90 degree with the disturbance, yeah, disturbance can be left or right or left, yeah, but particle is 90 degree, you are going to call it as transverse wave. Okay, similarly, if I say there are 5 kids again or 4 kids again holding hands. Yeah, now the student 1 or the kid 1, right, over here, let's say kid 1, kid 2, kid 3 and kid 4. So over here, kid 1, he started to move left and right. Okay, so left and right. Then next one left and right, next one left and right, and then the next one left and right. Yeah, first of all, the disturbance, wave is moving from left to right. From first to the next, yeah. Like question paper is transferred from the first to the last. Okay, so wave is moving, information moving, energy. Okay, energy direction or wave direction. And how the particle is moving? Particle is also moving left and right. So if I draw it properly, this is the direction of wave. Okay, and your particle is moving left and right like this. So when your particles are parallel, moving parallel with the direction of wave, have a look now, particle is moving parallel with the direction of wave, you are going to call this type of wave as longitudinal wave. Sound or the slinky that you play with, right? Yeah, over there also you can see the slinky is getting compressed and moved away. So yeah, compression and rarefaction, the particles are coming closer, far away, closer, far away. Air, when you are talking in air also the particles are coming closer, far away, closer, far away. Now, over here I am talking, right? So, particles coming closer, far away, closer, far away. Okay. So, here particle is moving parallel with the direction of wave. That is why sound is a longitudinal wave. Okay, now we know that yes, sound is a longitudinal wave. Now we have to understand that yes, where can sound travel? Moreover, if sound is needed by a medium or not, or sound certainly requires a medium for its propagation. So there are basic two types of wave. One will be mechanical, the other is non-mechanical. Okay, by far now I know sound is a longitudinal wave. Okay, so now I will say that yes, whenever we talk about sound, everyone, it requires a medium. You say, certainly if I talk about sound, right? So yes, medium can be either solid, liquid or gas. So any of the three medium can work for sound. That is why we say sound is a mechanical wave. When you are going to go there in the space, right, and if you try to talk, nobody would be able to hear you. Reason being, because yes, in the space there is vacuum void, no particles are there, and my sound require your medium, right, and it is a mechanical wave. So yes, you won't be able to hear anything, and yes, you are even trying too hard, right, yet that happens. Okay, so sound is nothing but a mechanical wave. Why? Because it requires a medium, be it solid, liquid or gas. Now, when we say that yes, sound can move in vacuum, no, it cannot travel through vacuum. Talking about what are non-mechanical waves? Non-mechanical waves are the one, yes, they do not require any medium. They can move through vacuum also. Your light rays, UV rays, they don't require a medium at all. That is why they are non-mechanical wave. Okay, so by far now we have a bit of understanding regarding sound. So let's jot it up. So all of you, sound is nothing but a form of energy. Okay, sound is nothing but a form of energy that certainly creates a sensation of hearing there in our ears. Moreover, sound is a longitudinal wave. Why longitudinal wave? Everyone, when we talk about longitudinal wave, okay, the particles are moving parallel with the direction of wave. Also, sound is a mechanical wave. It requires a medium. Okay, now let's say that how sound is moving, as I told you. So whenever we talk or whenever there is sound production, yes, the first and the foremost thing over here will be vibrating bodies. In order for production of sound, yes, you require vibrating bodies. Okay, sound is produced by vibrating objects. Either you take up a rubber band and try to pluck it, you will see the rubber band is vibrating. So yes, for sound production, vibrating bodies are very, very important. In all your instruments, we talk about tabla, sitar, guitar, yeah, they all have some vibrating parts through which, yes, your sound is produced. Okay, now coming back over here, so when we say a particle is vibrating about its mean position, what will happen? So all of you, when we talk about air, let's talk about air. Okay, have a look over here. Yeah, so when we talk about air, there are some particles of air. Okay, now moving all about, naturally they are moving all about. Have a look over here, right? Now I will explain. Okay, so let's say this is nothing but, a basic diagram of air particle moving normally. Okay, when no one is talking, no one is speaking. Yeah, when you started to speak, right, or when you try to talk, so what will happen? Of course, these particles, yes, they are in the mean position. Let me mark, they are in the mean position itself. Only consider this. Okay, only consider this. Yeah, what will happen? Of course, they are going to gain vibration, right? Of course, the vibration is going to travel, air it is. Okay, so the particle is going to go forward like this. Okay, let me mark it with yellow so that you can get. The rest are green. Okay, they are moving forward. And the rest are there at their particular place only. One second. Normally. Okay, can you see the particles are coming closer? The first one. Yeah, now the particles are here and it is going to move back, going far away, okay, and then coming back to its mean position. So everyone, what is happening over here? And then this, see, the moment is coming closer, right? Yes, this vibration will be transferred to the next one. So yeah, this whole process will now be occurring in the front ones, right? They are going to go forward. Yeah, so this thing will continue. That is where the propagation will take place. No. Okay, so everyone have a look when someone is talking. So what is happening? The particle is there at the mean position. Okay, it is going forward, then backward from its mean position and coming back at its mean position. Okay, the moment it is going forward, the moment it is trying to move ahead, right, reaching its extreme position, what is happening? The particles are coming closer, creating a region of compression. Right, particles are very, very close by, higher density, higher pressure, certainly you can say over here. Yeah, now the particles are far away, creating a region of rarefaction, low pressure region. Okay, so when we say that yes, someone is talking or yes, sound is getting produced, what will happen? Particles vibrate through their mean position. It pushes a region of compressed air, creating a region of high pressure that we saw. Okay, followed by a region of lower pressure that we saw. Yeah, so over here we say that sound wave is propagating by compression and rarefaction of the particle. Okay, so propagation is basically visualized by the pressure variance taking place. That is why all of you, I showed you this diagram, have a look. See, compression, rarefaction, compression, rarefaction. So you can mark also compression regions, okay, and rarefaction regions. Okay, certainly this diagram, this graph is basically very, very important in order to talk about the characteristics of sound wave. Okay, so I believe by far now you know about sound and you have a bit of clarity regarding sound. Okay, taking that how you can describe a sound wave, you can describe a sound wave by frequency, amplitude and its speed. So all of you, we are going to talk about each and every factor, and in order for the sound wave representation, of course, we use a graph and the figure as shown. This figure is actually telling me a lot of things. So before that, let me give you the actual scenario. Now this diagram will be clear to you. Have a look. See, compression region, particles are close by. Okay, so sound speaker is the source of the sound. Okay, so over here you can see both the cases, density variation also, pressure variation also, and the actual diagram that we are going to study about. Okay, now have a look. Particles of the air, they are very, very close by, so compression region. Okay, then rarefaction, compression, rarefaction, this is how propagation of the sound is taking place. Okay, and speaker is working. Similarly, have a look at the pressure variation. See, okay. So, of course, right, when we talk about pressure, yes, certainly over the atmospheric pressure, we had a word upon. Okay, so yeah, right. Now, density, have a look. How you are going to talk about that, okay, ma'am, how this curve actually came into picture. Everyone, simple. Over here, this is the mean position, right? And of course, moving at the particular top, right? Yeah, that is nothing but the extreme position. So, regarding that and taking that into consideration, we plot the graph. Yeah, now what is this A written, lambda written, and of course what it is showing, that we are going to understand. So now just last thing up, right? So yes, crest and trough, all of you, the below peak, right, that is nothing but the trough, and the above peak is nothing but your crest. Okay, so you can say hills and valleys also, but yeah, crest and trough, these are the words that we use. Okay, in order to talk about them. So one by one we will understand. Let's start with the basic thing. Okay, let's start with wavelength, everyone. All of you, let me draw the graph and make you understand. Okay, so everyone, this is nothing but the curve. Okay, it will continue. Yeah, now everyone, when we talk about the wavelength, yeah, wavelength is nothing but the distance between two consecutive crest or two consecutive trough. So all of you, look, this. Okay, this is nothing but your wavelength. Now some of the kids, they actually ask me, ma'am, why we have to take up the distance from here only, right? Why we cannot take the distance from this particular mean position itself? You can, but if you have to take up this from here, right, you are going to move from, okay, from one mean position to extreme position, then crossing the mean position to extreme position and coming back to the mean position. Then you have to take up this. Okay, but it's better that you take up either trough or either crest. Okay, so the distance between a lambda is nothing but the wavelength, that okay, how much distance your particle will travel. It is moving from the mean position like a pendulum. Understand, like a pendulum. Mean position to one extreme, another extreme, coming back. Yeah, that is nothing but your wavelength itself. Okay, so the distance between two consecutive or two successive crest and trough, okay, or successive compression and rarefaction, and anything you can take up, right, that is your wavelength. SI unit is meter, always meter. Okay, now taking this thing up, everyone, when we talk about time period, what do you mean by time period over here? Time period will be how much time will my particle require to move. Okay, so when we say that, okay, how much time taken by two consecutive compression or rarefaction to cross a fixed point or keep your life easy. Time taken for your particle to undergo a particular vibration we certainly talk about, right? Okay, or one oscillation we talk about in the pendulum, na? Yeah, but in NCERT, you're following the NCERT, yes, you have to follow these terms. The time taken by two consecutive compression or rarefaction to cross a fixed point. Okay, time period you're talking about, so yes, keep it in seconds. Okay, symbol capital T. Okay, what is frequency? The number of compression or rarefaction per unit time. So, how many compression, how many rarefaction will take place in 1 second per unit time? That we talk about. So, over here the formula, no, how it takes up. Frequency will be number of the actual formula regarding pendulum I am giving you. This is the pendulum formula. Okay, you can take that thing up if you are comfortable. Okay, time taken, number of oscillation. This is the pendulum formula. Okay, for the pendulum. Yeah. Okay, now SI unit over here will be hertz, and yes, the symbol, as you can see, symbol, or F you can take up, or you are comfortable with this, the particular symbol over here, it's totally upon you. Okay, last one is amplitude. Amplitude is nothing but the maximum, see, from the mean position, yeah, the maximum your particle can move. Everyone, amplitude, let's talk about. This is the amplitude. How much maximum your particle is actually able to move. Okay, you can take it from here also, both are going to be same. Okay, so amplitude is nothing but, yes, your magnitude of disturbance in a medium either on the side of the mean value. Okay, and A is the symbol. Now, lot of kids, they actually get confused that, ma'am, I am not comfortable with the frequency, I am not comfortable with the time period. So, it's better, and yes, the formulas remain the same. It's better if you are comfortable with the pendulum formulas, you can use that as well. Okay, need not worry. So, you know frequency is 1 by time period is 1 by frequency. Of course, you are going to use this. Okay, wavelength you are comfortable, amplitude you are comfortable, time period and frequency, I have given you a small hint on that. Okay, so yes, for frequency, number of oscillations by time taken, time period, time taken by number of oscillations, you can use that as well. Over here, in place of oscillation, we are talking about compression and rarefaction, same thing up. Okay, two consecutive compressions, yeah, or two consecutive rarefaction, same thing we are using. Fine. So, now coming on to speed of sound. Everyone, yes, when we talk about speed of sound will vary from medium to medium. Why? In solids, the particles are very close by. Okay, so in solid, the particles are very close by. So, yes, sound will have its fastest speed. Okay, in gases, sound will travel the slowest. Why so? Because the particles are very far away from each other. Right? So, when we talk about solids, yes, sound will have its maximum speed, or sound will travel fastest. Similar way, in gases, sound speed will decrease because the particles are far away. Why? Yes, sound requires a medium and mechanical wave. So, particle will play a very vital role. Okay, now sound travels to different media. We know mechanical wave at different speed. The speed of sound depends on some properties. So, everyone, what are the properties? So, first of all, it will depend upon the pressure, density and temperature. Okay, have a look over here, speed of sound. Yes, maximum in solid, then liquid, then gases. Okay, one basic thing you should know, the speed of sound in air, it is nothing but 331 meter per second. And of course, at 0 degrees Celsius, okay, temperature important. So, 344 meter per second at 22 degrees Celsius. Okay, Now, when a source emits sound with speed greater than the speed of sound in air, it creates a sonic boom which produces shock wave with lot of energy. So, everyone, I believe you have heard of this, sonic boom usually. So, when the source is emitting the sound with the speed greater than the speed of sound in air, so yes, the speed of the sound is greater than that of the air, then only the sonic boom would be created. Okay, and yes, shock waves of energy, of course, right, it is initially pretty much, having a higher speed than the speed there in air. Okay, that is why the shock waves are produced with lot of energy. Now, formula all of you, the speed of sound is nothing but wavelength into frequency. Yes, why? As you know, speed is nothing but distance upon time. Okay, so if I say distance into 1 by time is frequency. Okay, distance over here is wavelength. So, speed is nothing but wavelength into frequency. Okay, again, speed is distance upon time, the actual formula of speed, right? So, distance into 1 by time, if I do 1 by time is frequency, na? Right? Similar way, distance over here, what we are talking about distance at wavelength it is, so wavelength into frequency, that is how the formula came into picture. Okay, now moving ahead, we are going to talk about loudness. So everyone, loudness of the sound is basically depending on your amplitude. So all of you, if you know about amplitude, you can talk about the loudness of the sound. Okay, so how loudness is depending upon amplitude? Amplitude square. So if your amplitude is twice, yes, what will happen? See, amplitude, okay, increased twice. Yeah, what will happen to the loudness, everyone? Yes, loudness is depending upon amplitude square. So, twice the amplitude whole square. What will happen? Loudness will be increased 4 times. Okay. Similar way, amplitude is increased thrice. What will happen? Loudness will be increased 9 times. Okay, so if I know about the amplitude, have a look over in the diagram also. If I know about the amplitude, I can easily talk about loud sound and soft sound. Yeah, have a look. More the amplitude, look, compare. Yeah, more the amplitude over here, amplitude is more. So, of course, I will say louder sound. Yeah, moreover, last thing to point out over here, loudness of the sound is measured in decibel dB. Okay, yes, sound waves of more than 80 dB, right, they are pretty much harmful and painful to our ears. So, we try that, okay, the sound waves, we are talking about, and yes, lesser amount of amplitude is going ahead, right, or the loudness is pretty much less. Okay, now moving ahead, pitch. So, yes, in order to talk about the pitch, everyone, we say, right, that yes, here, pitch is depending upon frequency. If you know about frequency, you can easily talk about the pitch of the sound. Right. So, we say the characteristics of sound by which an acute or shrill note can be distinguished or a flat note can be distinguished, that is pitch. Pitch is the sensation of the frequency of an emitted sound. So, yes, in order to talk about, yes, pitch, you have to know about frequency. More the frequency, right? Yes, shriller your sound is. Yeah, and less the frequency, of course, flat your sound becomes. Have a look over here only. More the frequency, shriller is the sound, lesser the frequency, flatter is the sound. Okay, so when we talk about pitch, everyone, sound with greater frequency is shriller and having higher pitch. Then only you can say over here, na, higher pitch. Okay, sound with lesser frequency will be flat and yes, over here low pitch. Fine. So, yeah, in order to talk about loudness and pitch, you need to know about amplitude and you need to know about your frequency. Last topic over here is reflection of sound. Everyone, when we talk about reflection, I hope you remember light is a, we have talked about a bit of light over there, right, in the past videos as well, that yes, light undergoes a phenomena, that is reflection. Similar to light, sound also undergoes reflection. Okay, and yes, sound wave also follows the two particular laws. Okay, over there we said, right, that following on the same plane. Yeah, angle of incidence equal to angle of reflection over here also. Okay, so when a sound wave is incident on a liquid or a solid surface, it bounces back, and yes, in the same medium we call this as reflection of sound. Okay, now when we talk about that, okay, we are hearing the sound, reflected sound again, right? So we give it a special name. What is that? Echo. So all of you, the phenomena where a sound produced is heard again due to reflection. Yeah, this is called as echo. So all of you, I am producing a sound, and yes, I am hearing that sound again. But that is the reflected sound that I am hearing again. That I will call it as echo. Okay, so have a look. To hear a distinct echo, the time interval between the original sound, the going sound, and the reflected sound must be at least 0.1 second. Have a look, 0.1 second. Okay, now, what is happening over here? Reason being because in our ear, as sound persists in our brain for about 0.1 second, the minimum distance for the obstruction or reflective surface to hear an echo should be 17.2 meter. Yeah, multiple echoes can be heard due to multiple reflection taking place. So everyone, what it is talking about, basically in our brain, right, a particular sound is going to pertain there and persist there for 0.1 second. Yeah, so when I say that, okay, over here in our brain, it is pertaining there for 0.1 second. So yeah, the minimum distance, of course, right, in order to hear an echo also, minimum distance you would require. Yeah, so you can talk about the minimum distance as speed is equal to distance upon time. Okay, taking up the whole scenario, speed in the air, you know. Okay, so the minimum distance coming out to be 17.2 meter. Yeah, and so that you can hear an echo. So yes, this is the minimum distance you require. Okay, multiple echoes also we can hear. That is nothing but multiple reflection taking place. Okay, and in the movie halls we tend that, okay, there are no multiple reflection taking place. We don't want echo over there. So we put on some, foam there at the walls on the hard surface so that the sound waves can be absorbed. Okay, so the surfaces, they are not following reflection, they are absorbing the reflected sound. Okay, come over here, let's talk about reverberation. The persistence of the sound because of multiple reflection is called as reverberation. So audium, and have a look over here in the diagram only, okay, don't go ahead. Auditorium and your bigger halls, what will happen? They have hard surfaces and hard walls. Okay, so excessive reverberation will take place. That is undesirable for you again and again. Yeah, so that is undesirable, na? So we have to reduce this. Halls, there in the auditorium, we are going to put in the foam, or you can say, fireboard or rough plaster onto the walls in the roof as well, so that the excessive and undesirable reflected sound waves, they can be absorbed and you can only hear the particular sound. Okay, so yeah, in order to reduce these halls and auditoriums, they have sound absorbing materials on the walls and the roof. Okay, right? Now we had a word on lot of sound. The last thing would be audible and inaudible sound. All of you, audible sound waves, they will be that, okay, they are audible to us, we human beings. Okay, so the range, yes, for the audible sound waves, it is 20 Hz to 20,000 Hz. Any sound wave that is lying here, right, in this range, right, it would be audible to us. Okay, or you can call it as sonic sound also. Sonic sound. Fine. Less than 20 Hz or greater than 20 Hz, that will be, see, less than 20 Hz, greater than 20 Hz, of course, that will be inaudible to us, we human beings. Okay, now there are some animals, they can actually hear, and they can actually have this ability that they can talk about less than 20 Hz. So of course, some animals like dogs have the ability to hear frequencies of higher than 20,000 Hz. What you are going to call it? You are going to call this as, yes, your, higher than 20 Hz, of course it will be ultrasonic. Okay, not audible to you, but yes, audible to dog. Yeah, lower frequency will be called as infrasonic, that is less than 20 Hz. Okay, so when we talk about elephants, of course, infrasonic, bats, ultrasonic. Okay, moreover, objects that vibrate at frequencies of above 20,000 Hz produce sound that cannot be heard by us. We are going to call it as ultrasonic. So, in easy terms, you can say, yes, there is one range, right? Audible 20 Hz to 20,000 Hz. Yeah, less than 20 Hz inaudible, more than 20,000 Hz inaudible. Less than 20 Hz infrasonic, more than 20,000 Hz ultrasonic. Okay, and animals are there, they actually communicate, they actually produce some sound waves that are not audible to us, we human beings. Right everyone? So now this was the last thing up that is there in your syllabus. Keep on practicing, have a look at the videos, of course, share your views, and of course in the comment section any doubts are there, I would be more than happy to help you. Thank you so much everyone.